In this video, we're going to go over radioactive decay, which is part of nuclear chemistry. So let's go over the different particles that you need to know. And let's start with the alpha particle. The alpha particle has a mass of 4 and a charge of 2. The alpha particle is basically, it's the same or equivalent to the nucleus of a helium atom, so it can be written this way as well. That's an alpha particle. The next one that you need to be familiar with is the beta particle, which can be written like this. It has a mass of 0 and a charge of -1. The beta particle is essentially the same as an electron. Next in line, we have the positron particle, which is the antiparticle of an electron. So it has the beta symbol, but instead of having a negative charge, it has a +1 charge. So that's the positron. And then after that, you have the proton, which is much more massive than an electron. The proton has a mass of 1 and a charge of 1. And then you have the neutron. The neutron is neutral. It has a mass of 1 but a charge of 0. And then finally, the gamma particle. The gamma particle is basically a high energy photon. It has the gamma symbol, but it has a mass of 0 and a charge of 0. So those are some particles and their symbols that you need to know. So let's go over some examples. Let's say if we have nitrogen 13, and let's say it produces a beta particle, which can also be represented as the beta symbol, or you can put E for an electron. So that's the beta particle. What's the missing element? Now, the masses and the charges must be the same on both sides. So 0 plus 13 is equal to 13. So the missing mass has to be 13. Now what about the charge? -1 plus what number is 7? -1 plus 8 is 7, so the missing number is 8. To find the missing element, go to the periodic table and look for the element that has an atomic number of 8. So this is oxygen. So here what we have is oxygen 13. So that's how you can find the missing element. So this is called beta decay. The reason why it's called beta decay or beta production is because this reaction is producing electrons, it's producing beta particles. Now let's go back to this reaction. We need to understand the effect of beta decay. So notice that beta decay did not change the mass of the new element. The mass stayed the same. So during beta decay, the mass will be constant. However, the atomic number changes. The atomic number increased from 7 to 8. So beta decay causes the atomic number to go up. And the atomic number is basically the number of protons. So the number of protons went up. Nitrogen has 7 protons, but oxygen has 8. But what about the number of neutrons? The number of neutrons is the difference between the mass number and the atomic number. So nitrogen has 6 neutrons and oxygen has 5. So the number of neutrons went down. So let's understand what happened. We lost a neutron, we gained a proton, and nitrogen also lost an electron. So basically, a neutron in nitrogen was converted into a proton and electron. That's basically what happened. A neutron in the nitrogen nucleus was converted to a proton. The proton stayed in the nucleus, but the electron left. And so that's why we could see we have a decrease in the neutron number, an increase in the proton number, and the electron, it escaped from the atom, or from the nucleus of the atom. Now, the next kind of reaction that we're going to talk about is positron production. So we're going to produce a positron in this reaction. So if we're producing it, it's going to be on the right side. So this time it's going to be 0, +1, and let's use the beta symbol. Now, what's the missing element? Now, the mass is going to be the same. It's going to be 13. But now, the atomic number is going to be 7 minus 1, which is 6. So what's the missing element here? What element has an atomic number of 6? This is no other than carbon. So what is the effect of positron production? So this time the atomic number went down. It decreased from 7 to 6. So whenever the atomic number goes down, we said the number of protons decreases. But what happened to the neutron number? Well, 13 minus 7 is 6, so nitrogen had 6 neutrons. 13 minus 6 is 7, so now it has 7 neutrons. So the neutron number went up. So basically, a proton was converted into a neutron and a positron. So let's rewrite it a different way. So here's the proton with a mass of 1 and a charge of 1. It was converted into a neutron, which had a mass of 1 and a charge of 0. And it was converted also into a positron, which has a mass of 0 and a charge of 1. So a positron is just an antiparticle of the electron. You can see how it's balanced. 1 plus 0 is 1, and 0 plus 1 is 1. So that's what happened during positron production. A proton was converted into a neutron and a positron. By the way, what happens when a positron meets with an electron? When these two get together, they cancel out and they form a gamma particle. So as you can see, 1 plus -1 is 0. So they basically annihilate each other, emitting gamma radiation. The next type of decay we're going to talk about is electron capture. So what exactly is an electron capture? Well, sometimes the nucleus of an atom can capture one of its inner core electrons. And so let's see what happens. Let's say if we have arsenic 73. Arsenic has an atomic number of 33. And if the nucleus captures an electron, the electron has to be on the left side. So what element will be produced? 73 plus 0, well, that's going to stay 73. 33 plus -1 is 32. So arsenic is going to change into germanium if the nucleus of the arsenic atom captures an inner core electron. So let's see what happens within a nucleus. So the atomic number went down. It went from 33 to 32, so we lost the proton. The proton number went down. Now, the number of neutrons is the mass number minus the atomic number, so 73 minus 33, arsenic has 40 neutrons, and 73 minus 32, germanium has 41 neutrons. So we gained a neutron by acquiring an electron. So let's see what happened here. So in the nucleus, a proton, which has a mass of 1 and a charge of 1, combined with an electron to create a neutron. 1 plus 0 is 1, and 1 plus -1 is 0. So that's what happens during electron capture. The proton and the electron, they come together, they form a neutron, and the element changes. The atomic number decreases by 1. And now the last thing we're going to talk about is alpha particle production. So let's say if we have element PO, which has an atomic number of 84. And since we're producing alpha particles, we need to put it on the right side. So what's the missing element? So 210 minus 4 is 206. And 84 minus 2 is 82. So the element with the atomic number of 82, that is Pb, that's lead. And so this is alpha particle production. And basically, you just got to make sure the reaction is balanced. As long as the masses and the atomic numbers, or the charges, are the same on both sides of the equation, then you're good. That's it. So that's just an intro into nuclear chemistry and different types of radioactive decay. So that is it for this video. Thanks for watching and have a great day.